Graspable Math. It's an interactive digital math platform that helps students learn algebra and geometry by directly manipulating mathematical expressions in visual models. In this video, I'll give an overview of the platform, demonstrate a couple activities I explored, and then explain how it further supports student learning in many ways. So Graspable Math is different from typical math tools because it allows students to physically interact with math on the screen. Instead of only writing steps down, students can drag, rearrange, and completely transform expressions while staying within correct mathematical and algebraic rules. This makes math much more visual, interactive, and very exploratory. So from the teacher's side, there is a teacher dashboard. Let's see if I can get it pulled up. Here is that teacher dashboard. Right now, I only have one fake student in, but you would have your entire class be working through an activity. Um, this is one of the most powerful features of Graspable Math. It allows teachers to monitor each student's progress in real time while they are trying to solve the problems. What makes this especially useful is that teachers can see every step a student makes. So if I look in here, you can see each step that this student would have taken to try and find the slope of between two different points on a line. So the first activity I want to highlight focuses on finding slope using coordinates of 2 points. In this activity, students are given 2 points on a coordinate plane and asked to determine the slope. Instead of only using the formula like rise over run on paper, students can visually connect the 2 points and see how slope is formed from vertical and horizontal changes. So here you can see you're building up that distance between the vertical and horizontal lines to get the distances on the top and bottom, and then using that to find the slope. But not just for this activity. In algebra and geometry problems, the teacher can identify whether a student has made a mistake in calculating slope, misapplying a formula, or misunderstanding a geometric relationship. This step-by-step visibility that Graspable Math offers makes it much easier to give targeted feedback and support for each individual student. So what makes Graspable Math powerful is that students are seeing each step contribute to the final slope value that they get. If a student subtracts coordinates incorrectly or reverses the order, that mistake is visible in their work in progress. It's not just in the final answer, so it's very easy to see where you went wrong. So this helps students understand that slope is not just a formula, but a relationship between 2 points that describes rate of change. It's the relationship between that rise over run. The second activity I want to focus on is about the Pythagorean theorem. This is where students are visually transforming the areas to understand why the theorem works. So students are working with a right triangle, and then they can see that squares are built off of both legs of the triangle. The key idea is that the areas of the legs of the right triangle, or the areas of the squared legs of the right triangle, can be moved over into the square of the hypotenuse, and you can see that they're equal. Instead of simply memorizing that a squared plus b squared equals c squared, students can physically see how the pieces from the smaller squares combine into the larger one. This makes the theorem much more intuitive and easier to understand why it works because students are not just accepting a formula at face value, they're seeing a, if not rigorous, then at least visual proof of why it works. Using the whiteboard view, students or teachers can demonstrate how the squared regions on the legs break apart and reassemble into the hypotenuse square. This dynamic movement is something that's very difficult to represent clearly on paper. And then one of the biggest advantages of Graspable Math is that it makes mathematical thinking visible. With paper and pencil, teachers usually only see final answers in a few written steps, even less with some other math action technologies. But here, teachers can review the entire process step by step, which helps them identify exactly where misconceptions occur. Another advantage is immediate feedback. If a student makes an incorrect move, the system responds right away, allowing students to correct their thinking in the moment instead of carrying the mistake forward. For example, here, if we had lengths of three, uh, like you can't 3, 5 and say, actually, that part doesn't really matter as much. So if we've got like you can't add a 3 squared and a 25. It does that little shake, signifying that you can't do that mathematically. But so they have to resolve the square first and then add the two numbers together. So this encourages a lot of exploration. Students can try different paths, undo specific steps, and then without fear of ruining their work. So this supports a much deeper understanding and reduces some anxiety about making mistakes, which is really, really fundamental in building conceptual understanding and a positive math identity as a whole. So overall, I think Graspable math works well because it turns math from a static written progress or process into something more interactive and visual. Graspable Math is a powerful tool that makes algebra and geometry easier to access. It makes it a lot more interactive and a lot clearer for both students and teachers.